Hello, everybody. Welcome to our talk titled Refresh, Renew, Refactor, Modernizing a Large Android App with Many Users. I am Maya, and I'm an Android engineer at Luno. And with me is Andrey, my colleague, also an Android engineer at Luno. So to give you some background, the Luno app, you can see some screenshots on the screen here. And Luno makes it safe and easy to buy, store, and learn about cryptocurrencies. We have an Android app, and we have an iOS app, and we have a web interface. I collected some stats for you. And as of the 1st of October 2020, we had about 1.35 million active Android users. We have a presence in 40 countries. The first commit on the repository was Friday, the 25th of July, 2014. We have 329 fragment layouts. We have 8,918 lines of Java code and 250,912 lines of Kotlin code. We also have 51,941 lines of XML code. So what these stats tell you is that we have lots of users in different countries. We have a code base that has existed since 2014. We have many fragments, and we have an overabundance of Kotlin code and much less Java code at the moment, and lots of XML to deal with. So what did our framework look like in the past? We had entirely Java code base. We were using the MVVM pattern, but without Jetpack libraries. MVVM is model, view, view model. In some places, we were using the burrito pattern. So the burrito pattern is where you have activities and fragments, but all of the business logic is stuffed inside the activities of the fragments. We had typically a pattern of a single activity with many fragments, not only one activity in the app, but that was generally the pattern. We were using async task. For our network, we had a REST interface with retrofit, and the payload was mostly JSON. And then we were using event bus to talk among the fragments and to coordinate things. And we had some tests, but as you all know, that with this kind of architecture pattern, testing isn't really easy to do. So what do we want to have? We want to have a code base that is largely Kotlin. We want to continue using the MVVM pattern, but we want to use the Jetpack libraries. We are keeping with our pattern of a single activity with multiple fragments. Instead of async task, we wanted to move to coroutines. We wanted to keep our REST and retrofit combination, but use protobuf for the payload. And we definitely wanted more tests. So just a little bit of definition around refactor and migrate. So I looked at the Wikipedia and I paraphrased slightly. To another system, and hopefully also without changing behavior. But of course, with neither of these, it's always possible to not change the behavior. And in another thing that can happen is that if you're migrating, say, from async task to coroutines, or if you're migrating away from event bus, you will have to do some refactoring because the implementation is different. So you would ask, why do we want to do such a huge task by changing the whole of the code base? So from a developer perspective, we have lots of reasons why. We prefer Kotlin, we want more tests. But why would the business want to do this? So we were fortunate that Luno decided to make our customer journey easier and was looking at all the screens and cleaning things up. And so the developers took the chance that when we were changing all of the screens, we can at the same time implement new libraries and new patterns to make our lives easier as well. So now the agenda. I'm going to refactor our agenda a little bit. I've already told you about the overview, so we can delete that piece of code. And now I'm going to split responsibility. First, Andrey will tell us about Kotlin migration, migration tips, event bus and coroutine migration, and some protobuf migration. And then after him, I will talk a bit about the architecture and how this helps us for testing. I will tell you how we structure our remote teams so that we can do this kind of migration easier. I will give you some insight into our continuous integration and continuous delivery pipeline and give you a sneak peek on what's next.
Okay, thank you, Maya. Hello, everyone. I want to share our migration experience step by step. This is long-term and complicated process, so it should be done responsibly. I will provide Kotlin conversion as an example, because this is the massive project. So, the first question is how to start migration. You should prepare product request. Product request is a document which describes problem and measure of success. For Kotlin conversion, I can advise that this is not necessary to achieve 100% of conversion. Better to leave some classes in Java. For example, legacy classes, classes that will be removed soon, or third-party classes with complicated logic. The next step is define champion. Champion is a responsible person who should know status and progress of current project. I was champion of migration project, and this is very important role. Champion interested in completing project, so migration go faster. Also, champion shouldn't complete project alone. Tasks can be created and divided between team. Also, champion should create technical design document. This is document which describe problem and solutions. It could be drawn up in free form or from some template. It allows us to define scope of work. In our case, it's all Java classes, and we can sort it by priority and accept classes that shouldn't be converted to Kotlin. Based on technical design document, we can estimate time. From my point of view, technical design document is very helpful. When you create them, you always analyze project, and it's very, very helpful. So it can be used not only for migration, but for any other project. Also, you can use design document to motivate product owner why you should do this project. And one of the most important steps is burden sharing. Previously, I mentioned that champion shouldn't complete project alone. One man, no man. Migration is responsibility of the team. That's why tech debt tasks should be created and divided between whole team. Now I want to share conversion from my point of view. The first one is do refactoring. It is good idea to refactor classes after Kotlin conversion. You don't know when it will possible to return for refactoring again. So try to reduce complexity of your code. So after refactoring, code should be simpler and cleaner. I always try to split up giant function into smaller because it's easy to read. Another one is create unit tests. Unit tests cannot fail if you don't have any, but this is not the way. Migration and refactoring give great chance to create unit tests. But unit tests can be added before migration. And in this case, it gives an opportunity to make sure that your class is not broken. Personally, I think that unit test is very helpful. During creation, I always check function logic, and that's how I found few bugs. Don't trust converter. When you use Android Studio Converter, always check result. It works fine, but in most cases, code can be improved after conversion. The most important is always check places where Kotlin call Java classes. The most common crash that came after migration is null pointer exception, when Kotlin expect non-null, but Java return null. Always check twice source Java code, and if you're not sure, better to use nullable Java object. Take a look at an example. Here I was not sure, can device name be null or not, but after checking the source Java code, I am sure for 100% that this is impossible. The next one is always test changes. This is very important part of migration. Don't be lazy. Always check changed code, even if you're sure for 100% that it's worked fine. After migration, you are author of code, so testing is your responsibility. Don't expect that someone do it for you. If you're tired, just rest. Be honest, this is my weakness. When I know the goal, I try to reach it in any cost. So this is wrong, because after big project, I feel very tired. So much better is combine different tasks, and if you feel that some tasks make you unhappy, better to change focus for some period of time. And review is very important. Even the most experienced developers make mistakes. Always ask for review, because it will reduce chances of bugs. And one more tip: don't try to change the vault in one request. Very often during migration or refactoring, you want to change half of application, start improving one thing, you improve another, and then stop after changing almost 100 files. But you shouldn't do it. Better stick to the rule. One request, so one problem. It is better to create requests as small as possible. But what is small request? How to understand that your request is small enough? Actually, this is a good question, and I think it's based on developer taste. But personally, I have few rules. If class size is up to 100 lines, or this is small data class, then 3-5 classes per request is fine. If class contain complex logic, or class size is more than 300 lines, better to create separate request. In other cases, 2-3 classes per request is also fine. Try to split different tasks into few requests. Kotlin conversion shouldn't be combined with refactoring. This will allow reviewer to easily find out if something is missed. Take a look at an example. Comparing line by line will allow us to mention if something is missed or something is broken. But after refactoring, it will be complicated. But refactoring can be combined with creating unit tests, or Kotlin conversion of fragment with conversion of view model. Another one is always check request before send it to review. During self-checking, some small, sometimes even serious mistakes can be noticed. It will prevent reviewer from losing focus on minor errors and focus on more serious ones. Take a look at an example. Here I made few mistakes. I forgot about formatting, and this code can be improved by using map operator. But we missed that this code ran on the main dispatcher. This is serious mistake, but we focus on less important things. And the last, I think the most important advice: don't be afraid of mistakes. This is okay that after rewriting a big amount of code, some small, sometimes even serious mistakes can be appeared. Don't be upset. There are no mistakes, only for those who do nothing. Be ready that this is possible, but try by hard to prevent it. Find root cases of bugs or crashes and prevent it in future. So now I want to share our results of migration, and I think all of us know advantages of Kotlin. I will mention only the most important from my point of view. After migration, the number of null pointer exception has been reduced almost to zero. Now we can use the latest features such as coroutines, and the average file size has decreased by 21%. Another one is proto-migration. Even bus migration. Even bus we use to get network results. So we register it, and after network call, results arrive to function that we mark with subscribe annotation. And it's very important not forget to unregister even bus. So even bus have a lot of disadvantages, such as very complicated debug process, high probability of error. Changing it in one place can break application in unknown place. It's very difficult to read code. It's a lot of boilerplate code. So even bus was okay, but in the past. Now we have much better solutions. For example, coroutines. Coroutines allow us to write almost synchronous code. It's easy to read, easy to debug, easy to test. New developers take less time to adapt. Take a look at an example. After migration, code looks much better. And one more, it's protobuf migration. Protobuf is Google extensible mechanism for serializing structured data. It allows us to define structure of model and generate this model for backend, web, Android, iOS. It also reduces transfer data size and speed up request. Protobuf is impossible without backend changes, so it relates not only for Android team but for all other platforms too. I think that the result is pretty interesting, so I want to share it with you. I analyzed the biggest hour model before and after migration, and seriously, I was shocked. 50% faster and 70% smaller. This is a really good result. But what benefit for smaller model? For this data structure, I create JSON and proto models. After encoding, JSON take 360 bytes and proto only 158 bytes. This is 56% smaller. I think it's still good result. Okay, thank you for your attention. Maia?
Okay, so I will look at our architecture choices and how the change in architecture helped us to improve our testing coverage. So this is the pattern that we are following now. We have an activity with multiple fragments. Each fragment has one view model or more view models if they share, and we use live data observables from Jetpack library to talk back to get the information. We connect our view model with our layout using data binding. Then the view models can have a repository, and the repository connects our view models with either the database or the network calls. The benefit of this situation is that we can keep Android framework classes outside of the centerpiece. So the view model and the repository may have some business logic in it, and those we can put unit tests for those classes because they don't have access to the Android framework classes. And this improves our unit test coverage. So, but if you'll say to me now, I have a burrito pattern, how do I even get out of the burrito pattern into the new pattern so that I can add more tests? So my first tip is that the @deprecated annotation is your friend. You can see here we marked the base view model with deprecated. You can leave a message saying what it needs to be migrated to, and you can even add the replace with option to help the IDE to help you when you're trying to convert your models. This way, the IDE will help you to show the classes that are deprecated, and this is especially useful for remote teams that work that are not co-located. As you can see here in the IDE, this is a little screenshot from the IDE, and then the deprecated classes will get a strike through. So even though a developer in another team doesn't know that this class might be deprecated, when they see this, they know they should not be using this class anymore. The next thing is if you're trying to convert a piece of legacy code into a new format. So my first suggestion is to break this up into many steps. And the little recipe is like this. First, you take the class, say it's the add bank beneficiary fragment that you want to convert. You rename it to call it legacy, and you commit that change so that you can keep the history of the fragment. Then you add a feature flag into the code. Then you make a copy of the class without the legacy prefix, and then you start refactoring and writing tests. So I've put refactor and then write tests in that order, but you can start writing tests before refactoring. But sometimes if you haven't refactored yet, you can't write tests at all. And the other important thing to remember here is that it helps if the whole team uses the same naming convention or folder convention when they're moving things to legacy classes, because this just helps it to be searchable. So now in the previous slide, I mentioned feature flags. At Luno, we have quite an interesting implementation of our feature flags. First off, the feature flags are controlled by the backend. The backend can set the flag depending on whether you're on staging or on production. It can control if people inside of Luno have access to a feature or if it's people outside of Luno. It can be controlled by the app version. So what this is useful for, you can say that an older version of an app keeps the old version of a feature or the unconverted version of the feature, and a newer version of the app might have the feature exposed. And also the feature flags work for iOS, Android, and web, all of our front end. On the other end of the backend is what we have is a thing called Luno Labs. So on the right-hand side, you see a screenshot of our Luno Labs setting. If you enable Luno Labs, you then get access to different feature flags which the user can toggle. And we allow beta users to opt into some features, and then even our production users to opt in for some features. This means we can start when the feature is ready to roll out, we can start testing the feature, and a user can choose if the feature is not working for them at that time, or if there's a problem and they want to report it to support, they can still roll back and use the previous version of the code. So now our next slide is one mission, one team, and this is how we set up our team so this can work. So here I have a picture of our teams. We have large distributed teams all over the world. You can see on the left-hand bubble, there's Andrey, he's in pod frontend. So that particular team is responsible for driving the tech debt, driving the migrations, and driving the refactoring. Andrey there is the champion for, say, Kotlin, the Kotlin conversion. And that team is the one that does the research on how these migrations should happen. Now, I'm at the bottom there in Pod Exchange. I'm in the team that writes features for the Exchange part of the app. And so I'm busy writing my features, but I can get the examples and the guidelines from Pod Frontend on how to do the migrations. So typically our teams, like Pod Exchange, where I am, I'm the Android engineer, there is an iOS engineer, a web engineer, maybe a backend engineer, and also a designer, so they form a cohesive team. So our teams speak to each other asynchronously through those documents, the tech design documents that Andrey explained with comments in that, of course through Slack, but also the shared code in the Git repo is another way that the teams talk to each other, because the teams can see how the code changes and what the patterns are and how they change. In addition, we have a code review tool, and many of our asynchronous conversations happen in this code review tool. So that's for the asynchronous communication. As for meetings, we try and minimize those because they can take a lot of time. We have a thing called No Meeting Tuesday, which allows the teams to focus on in-depth work on Tuesdays and not be interrupted. But we do have a thing called a meeting of minds. So what this would be is that all of the Android engineers on all of the teams meet once every 2 weeks for half an hour. And this is the forum where we can discuss maybe what patterns we want to do, what new industry standards are coming up. And this builds a cohesive Android team and guides the direction of the refactors as well. So now we all know developer time is limited. And so how do you actually manage to do all the tech debt and the refactor? So as I see it, there are 3 pools for developer time. There might be support requests like bug fixes. There's internally the team that want the tech debt done. And then there are the product owners who have requests for new features. And none of these 3 pools can be ignored. You need to fix bugs, you need to detect it, and you need to do new features. I've seen suggestions for 20% tech debt, but I think this doesn't need to be a hard and fast rule. If you're pushing to get a feature out, then maybe you would spend more time on features, and then maybe you have a downtime afterwards, or you have a support section. The thing is just to balance between these 3 focuses of the team. So I'll have some quotes for you from the team just to see, for you to see what their perspectives are. So Charles is on the wallet team, and he said, set an expectation that any changes to existing functionality requires a refactor to new architecture, and new features are implemented in a new way. And then my quote is, refactoring is like brushing your teeth. A little bit every day is better than 2 hours once a month. And hopefully future Android engineers on our team will say, I love Kotlin, testing, and coroutines. So now on to our continuous integration and continuous delivery system. We use Jenkins, and the process starts when you make a pull request, the unit tests are run on Jenkins. The next thing that happens is that every 2 hours, we build a debug version. Now, a debug version can be installed in parallel to a beta or an alpha or a production version, and the debug versions get distributed using Firebase. This allows our designers, our product owners, and the team to get a fresh version of what's the latest in our develop branch immediately within 2 hours. And it's also a safe space. If you break something, you know you can fix it, and within the next 2 hours, someone will get a fixed version, and the designers, product owners, and team can choose which versions they want to install and test. And this allows us to get quick feedback from our designers, product owners, and our team. The next step is we have internal and alpha versions being released, and those are closed versions, and they get released through Google Play. We also have public betas and public production versions that also get released through Google Play. Now you see I've put a little train there, and that's because we follow the release train process. And what this means is that we have a production release going out every 2 weeks. So this is a diagram of our release process. It looks a bit complicated, but I'll walk you through it. So if we start at the bottom, on the bottom left, you see we are working on, say, version 1.0.1. So when version 1.0.1 goes to alpha, just about at the same time, we're rolling out version 1.0.0, which is going out to production. So we're monitoring what's happening in production, but we're still working on our develop branch. By the end of that week, whatever's landed can make it into our beta version, which gets released publicly on that Monday again. So at that point, version 1.0.1 is out in beta. And then we usually cut a release branch and have a look at the stability. Then by the next Monday, we roll out our next production version. We're rolling out version 1.0.1, and then the whole process starts again. So I've shown you 2 weeks, but if you think about the work that goes through to get a version out into production, it's probably about a month, because there's a week's worth of work before the alpha, then there's the beta, then there's the release branch, and then production goes out, and then we monitor production because we do phased rollouts. So now I'll give you an overview of how this works. So On the vertical axis, we have the team culture and we have the balance of the developer time. And on the horizontal axis, I've got the processes. So what you want is you want to change. When you need to change, you need to be able to change, and the team and the developers need to feel as if they can change. And to be able to do that, we have regular releases. We have the debug releases and we have the production releases coming out regularly. And this allows us to change quickly. But balancing that, we want to have the trust of our users. So we don't want to break things for our users, but also we want the trust of our product owners, that so they know that we will get around to building their features. So it's a balance between change and trust. And we use the feature flags to control and allow us to roll back if there's a problem when we make mistakes, because everybody makes mistakes. So now, what's next for us? I would say never stop refactoring. But with the way our teams and our processes are structured, we're set up to be able to do this. So what do we want to do next? We want to complete our migration. We still have some onboarding screens that need to be migrated to the new architecture pattern. We want to use MVVM and Jetpack everywhere and have consistency. And as the protobuf API changes come through, we want to implement those as well. Then we also want more unit tests, and we've just started building our integration tests and our functional tests. And then, of course, there are other areas that are now opening up that we can look at. We can look at our startup and see if we can make it quicker and cleaner. We can improve our dependency injection. We can change our navigation. We can implement the next shiny thing. But with a team structure and a process structure like this, we are able to do this. And now we are ready for questions. Aha. I think, Andrey, do you want to take the first one?
Okay. Let me read it.
You can read it aloud.
Yeah, of course. Also, you have less exceptions. Do you find those ones have harder to debug? Since Kotlin relies code generation, I found that stack trace invaluable are very hard to follow. Since my roads have no source Java code. Actually, yeah, this is really annoying when you cannot take a look on source Java code. So actually, it's just try to always check Crashlytics to find out the most annoying exception and try to catch it or fix it as fast as possible. So in this case, we have no solution how to fix those exceptions.
Okay, I'll take this one. Did the whole team have to be trained for this migration, or did everyone have the expertise for that? I think we didn't all have the expertise, but the way that the teams work at Luno are that we are sharing our knowledge among the teams. That's one of our values, to share the knowledge among the teams. And so we kind of set it up this way to be able to work this way. So our migration processes have grown with our project.
Next one about feature flags. Maia, can you?
Let me see. Your feature flags intrigue me. Are you actually allowing the user to try a feature while still in alpha beta? Okay, so what we do is we test it internally first, right? So we're testing it in debug, and then the feature might go into alpha and only be available on staging. And then the people inside Luno will test this feature. And then once we're really quite sure that the feature's working well, we will release this feature to our beta users, and the beta users are public. So beta users opt in to be able to see new features. So say, for instance, I can't think of a good example. We just recently released market orders. If a beta user is interested in market orders, they can enable the feature flag. But generally, beta users are in a position that they will give us feedback. So if there's a big problem, then the beta user reports it, and we can switch the feature off completely. And then once that is stable, then our public users can try the features out as well. So yes, we do publicly allow people to try new features, but only after we've tested it ourselves. I think one more thing to add about the feature flag, is that since it's controlled by the backend, it's literally just a code push to the backend, and then that will affect all the apps that are in the field. And it means that the apps don't need to be reinstalled. We can just control it from a flag that lives on the backend.
One more question from CI. Maybe it's also to Maia.
Okay. Why use building every 2 hours instead of on, for example, merged PR? Are there too many PRs, so this is more efficient? I don't know the decision because I wasn't part of that process, but I can tell you from a practical experience, sometimes the PRs come in and the poor Jenkins server is like building like crazy, and then it kind of gets clogged. So we have two processes running. We have the one that runs for the PRs, and then we have a separate one that does the releases. So that's just to stop that blockage. So from that observation, I would say that maybe sometimes we do have too many PRs, and that it's probably better to just get a build every 2 hours.
Okay, another one. How does live data scale with complex, extensive data models? Looks fine for small projects. Actually, this is a good question, and we use data binding. So this way we remove a lot of live data. But for complex screen, yeah, it's really annoying that we should have a lot of live data. But you can always split your view model if you feel that your view model is too massive, for example. But I don't know how to answer because, live data is a problem for very complicated screen. But I think that complicated screen is not that not the best user experience. So I don't know.
Okay. Yeah. I can add something there. So I recently built quite a complex screen. It's the screen where you put the exchange order in. And I had lots of live data and it was driving me crazy. And I'm in the process of refactoring to use the model view intent style where I have one state and the flow of the data just goes through once. And I've actually replaced the lots of live data. So I'm busy replacing lots of live data with one live data which has just the state objects. So that was the way that I looked at that. Okay. Oh, this is a contentious question. Andrey, do you want to take it?
Yeah, sure. Hey guys, are you using Coin for DI? Actually, no, but we have plans to use it in future. Currently, we use self-writing DI. It's like a service locator, and we use it to dependency injection. But it have a lot of disadvantages. So maybe the next our migration it will be to Coin. So that's it.
Okay. Does your view models grow very big when they are shared between multiple fragments? Okay. So I think from that perspective, the last piece of code that I refactored, I tried to keep the things that match that particular fragment to be in that fragment, and only things that are shared, like maybe there's some data that needs to be manipulated. Say, for instance, all trades coming in from the back end that need to be manipulated, and make sharing of view models to be the exception, not the rule. So to try to have the pattern, one fragment, one view model, so that you know that that screen's handled there, and only use shared view models if you have something that truly is spanning multiple view models. I hope that answered the question. Do you want to take the next one, Andrey? Oh, how do
it's about Espresso, but currently we don't use it.
We've only started writing our integration tests, so we don't. We will have to handle broken and flaky Espresso Android tests. Okay.
Next one is, did the whole team have to be trained for this migration, or did everyone have extensive for that? So actually, no. We learned in the process. So all the tips that I mentioned during this speech, it's like our real experience that we got after some time. And about don't try to change the vault in one request. It's really my tip, because I always try to change half application, and this is wrong. So that's why I mentioned about review, because after some period of time, when you got a lot of notes on your review, so you get experience, and then migration go faster, and you have less some notes from your other teammates. So I don't know how we can train other developers in your team, but I think just start it, and then you will create some rules, and then migration go faster, I think.
Do you want to take the one about Android X? Where did it go? Okay, which code review tool are we using? We're using Arcanist, which is Fabricator, which is a PHP thing, which is really strange and sometimes confusing, but mostly works. So that's the tool that we're using. Okay.
Another one, feature flags, it's also for Maia.
How do you handle testing all the combinations on feature flags? Oh, did it go away now? Are we out of time?
I think yes.
Okay. All of our libraries are Android X, right? We use live data for Android X. So there was a question on that.